This is a walkthrough of Problem 1 on Exam 2 of Module 12 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1, a particular tuning fork radiates sound at a frequency of 440 Hertz. This sound has a wavelength in the air of 80 centimeters. The tuning fork is wrong. The sound waves emanate out, hit the two slits, go through the slits. They're in phase at the slits. The first minima and the sound intensity are directly across from the slits, which are a distance of 4 meters away. What is the spacing between the slits? To 3 significant digits. So we need to relate the path difference to the wavelength at the position of the first minimum. Let's just pick the top minimum. It doesn't matter which one we do. We can put the path lengths in. There's our 1, and there's our 2. R2 is longer. They're in phase at the slits. They get out of phase because this distance is longer. And if they're out of phase by half a wavelength, which they are, that's the location of the first minimum. It's given that the wavelength is 80 centimeters. At the position of the first minimum, the path difference is half a wavelength. In this case, 40 centimeters. R2 minus R1 is 40 centimeters, the path difference. R1 is trivial. It's straight across. It's 4 meters. To get this one, we need the Pythagorean theorem. So R2 is 4.4 meters because it's out of phase by half a wavelength. It's 40 centimeters longer. So now we can focus on this blue triangle here, put in the lengths. That's 4 meters, that's 4.4 meters, and that's D, the distance between the slits, and that's what we're looking for. So we can write Pythagorean theorem. A squared plus B squared is C squared. There's the hypotenuse. We want to solve for D, so we solve for D. Subtract the 4.0 meters squared and take the square root of both sides. We get 1.83 meters. And that's the answer to the question. The distance between the slits is 1.83 meters. That's problem 1.